Hello everyone, this is Mesut Özda. In this video I cover data analysis with the Pandas library in Python using Jupyter Lab. If you enjoy this video, please hit the like button, comment and also subscribe to my channel. Let's get started. Pandas in Python stands for Panel Data System. It's a library for loading and manipulating data. So data in Pandas is stored in two fundamental data types. One of them is data frame. So data frame object type, it's meaning two-dimensional data object with index, and it's used for tabular data organized in columns. The other one is series, and its meaning is one-dimensional data object with index, and it's single time series of data. Pandas behaves very similar to NumPy arrays. So it can be used as input to anything in NumPy, SciPy, or scikit-learn libraries. The main difference from NumPy arrays is its indexing that we are going to cover in the next slides. And it's used in production in many types of industry. And in order to install it for the Anaconda users, you just type on your terminal conda install pandas, or for other users you can also install it with pip install pandas. Let's have a look at the data frame object type within pandas. So when working with tabular data, such as data stored in spreadsheets or databases, right, pandas is exactly the right tool for you. Pandas will help you to explore, clean, and process your data. In Pandas, a data table is called a data frame. It's similar with data.frame in the statistical language or package, the R language. Okay, and it provides data manipulation with integrated indexing, and it supports homogeneous and heterogeneous columns. In addition, Pandas supports the integration with many file formats or data sources out of the box, such as CSV, Excel, SQL, JSON, and so on. So importing data from each of these data sources is provided by function with the prefix read underscore. For example, read underscore CSV. So it's similarly the to underscore CSV method is also used to store data. If you have a look at the practice on the right hand side, as always, we always import the library first. So from pandas, import data frame, right? And if you want to use some shorter version, we can add this syntax as df, okay? And then as you see, we have a dictionary here, which is data, and its columns are state, year, and pop. And then we can also assign this frame object, as you see on the right hand side, with the df method, and then its input is this data that we defined, and then we can print and you see the output on the bottom. Within data frame, order of columns or order of rows can be specified. So, and columns not in data is going to have none. So what is none, right? None is for missing values. It stands for not a number, also referred to as an A, not available, right? As data comes in many shapes and forms, Pandas aims to be flexible with regard to handling missing data. While none is the default missing value marker for reasons of computational speed and convenience, we need to be able to easily detect this value with data of different types, like floating point, integer, boolean, and general objects. So data is from the previous example, okay, if you look at the practice, we define the frame2 object that takes df and its parameters data. So that data is from the previous example, which does not have the column depth, okay? It only has the year, state, and pop actually. So but when we add this column depth, the values for each row is going to be assigned as none. Here, outer dictionary keys are defined as columns and inner dictionary keys are defined as row indices in data frame. In this example, here we have another data called pub, okay, and its outer key values are Nevada and Ohio are defined as columns, okay, and inner key values 2001, 2002, and 2000 are defined as row indices. And next method that we have within data frame is transpose method. So pandas.dataframe.transpose. It transposes index and columns, okay? So it reflects the data frame over its main diagonal by writing rows as columns and vice versa. The property T is an accessor to the method transpose. Transposing a data frame with mixed data types will result in a homogeneous data frame with the object data type. In such a case, a copy of the data is always made. Here we are going to cover index, columns, and values methods within data frame. In this example on the top, we use the frame 3 data from previous slide. Okay, here we can name our index as year. We can also name our columns as state. Next, we have the index method. It returns row labels of the data frame. Here they are 2001, 2002, and 2000. The columns method returns the column labels of the data frame. Here they are Nevada and Ohio. And next is the values method. It returns a NumPy representation of the data frame. Only the values in the data frame will be returned. We can also retrieve a column within data frame. In the first example on the top, the syntax is, as you see, frame inside square brackets in quotation state. And the second way to do it is frame.state. So they both return the same output, which is the state column. We can also retrieve rows by using log or ilog. So what are the differences between log and ilog? Let's have a look. On the left hand side, if you see, log is for using indexes and ilog is for using positions. So in particular, log gets rows or columns with particular labels from the index, whereas ilog gets rows or columns at particular positions in the index, so it only takes integers. So let's have a look at the example in the middle. So we have the same data and then it has the state, year, and pub columns, okay? So and when we create the frame 2 object, we also put a det, which is gonna end up with values none in the output, as you see. So frame2.log in square brackets A, it's going to give us the row A, which is 2000, Ohio, 1.5, and none, okay? And then frame2.log A and B is going to give the values for the rows A and B. And then we have frame2.log A from A to E, and then only state and pub columns, okay? So another syntax we can use for frame2.ilog 1 to 3. As you see, we are going to only see B and C indexes or rows. And then we have frame2.ilog colon and 1 colon 3. We are going to see all the rows or indexes, but only state and pub columns. Here, besides log and ilog, individual elements or rows can be modified in some other ways. For example, in the middle, you will see that the det column of frame 2 is assigned to 0. So for all the rows that belong to that column will be 0. Second example, we can assign those values from 0 to 5 using the range method. Okay, moving forward on the right hand side, we can assign some values using the series object type within Pandas, right? We can specify only the certain rows that we want, such as only A, C, and D rows as 10 in this example. In that case, B and E will be assigned as none. Okay, so we can also delete a column with using del method as in the last example. Here are some more operations regarding to indexing. So we can import NumPy as NP, right? And then we can create a data using NP with the arrange function and the reshape function. So what will arrange do? Arrange 9 is going to generate 9 numbers starting from 0, okay? And then we can reshape it to 3 by 3 matrix. And then next we can create our frame object with the data frame and then assign this data and then name our index, which are the rows, with R1, R2, R3, and name our columns as C1, C2, C3, okay? And then we can print our frame C1 between the square brackets that you will see the values 0, 3, 6 for the rows R1, R2, and R3 respectively. And then we can also use the log method that we have seen. So basically log is going to take the R1 row and it's going to print the columns C1, C2, C3 with the values Z1, 2 respectively. And then we can also give the frame two parameters, which is C1, that's the column 1, and R1, that's the row 1, which is the value 0, okay? And on the right, we will see frame C1 and C3 under square brackets, and then you will see those columns and the values for each row, okay? And then same thing, you can do it with a frame.log method and R1 and R3 rows, so it's gonna give you all the columns for those two rows, okay? And then we can also print the R1 row with using log method, and then as you see we have frame.ilog colon 2, so it's going to give you the row 1 and row 2 for all the columns, and then frame in square brackets column 2 is going to give you the same output. And then on the very right hand side you basically check for each values if they are less than 3 by this syntax frame less than 3, and then you will see the Boolean output, right, which is going to be either true or false for each value. And then you have another syntax here that you see basically assigning the values to 3 if they are less than 3, otherwise they will remain the same, okay? And the next one you're going to have the frame C1 and is if they are equal, if they are greater than the 0, that's going to give you the output. And then if you have the last example frame C1 is greater than 0, it's going to give you the rows that belongs to C1 if they are greater than 0, which is true for those 3 cases. Here are some other data frame functions. So let's create our frame by naming the indexes and columns. So index names are ordered as A, capital C, capital B, and the columns are B, A, C. So where we have a sort underscore index method, which is going to sort the indexes, the rows. So as you see above, it was capital A, C, B, but now it's A, B, C. Okay, and then if this sort index takes the parameter x is equal to 1, then it's going to sort the columns. So as you see, it was BAC, okay, on the top. Now it's ABC. On the right hand side, we create the frame data with the data frame, and then the data frame takes the input from the numpy, so np random rand integer, basically creating 9 values from 0 to 10, and then we reshape them, and the indexes are r1, r2, r3, which are the rows, and the columns are c1, c2, c3. So, and we also have the sort values method that takes the parameter in this example by is equal to c1. So basically the c1 values were 8, 4, 6, but now they are sorted. So as you see, the row number changed because they are sorted as 4, 6, 8. And then underneath we have the sort values axis 1, okay, and meaning that this time the columns are going to be sorted. So as you see, R1 is 088 and R3 is 369. Here are some other data frame functions. The mean method returns the mean of the values over the requested axis. Here in this example, we select axis as 0 and we don't consider the data with non-values when we calculate the mean. The sum method returns the sum of the values over the requested axis. This is equivalent to the method numpy.sum. The compSum method returns cumulative sum over a data frame or series axis. It returns a data frame or series of the same size containing the cumulative sum. The describe method generates descriptive statistics. Descriptive statistics include those that summarize the central tendency, dispersion, and shape of a dataset distribution, excluding non-values. It analyzes both numeric and object series as well. As data frame columns sets of mixed data types. The output will vary depending on what is provided. For numeric data, it returns mean, standard deviation, max, min, 25 percentile, 50 percentile, 75 percentile, and so on. For non-numeric data, it returns counts, unique, or the most frequent item, etc. Core method computes pairwise correlation of columns, excluding null values. Pearson, Kendall, and Spearman correlation are currently computed using pairwise complete observations. Core width method computes pairwise correlation, but the pairwise correlation here is computed between rows or columns of data frame with rows or columns of series. Data frames are first aligned along both axes before computing the correlations. Another concept worth to mention in Pandas is how to handle missing data, right? So as you see on the left hand side, starting from the top left, in this example, let's create our data that has none values, okay? So data frame dot not null is an alias for data frame dot not na. It detects existing non-missing values. It returns a Boolean same size object indicating if the values are not an A. So non-missing values get mapped to true, and A values such as none or numpy.nan will get mapped to false values. Okay, and moving forward, the Pandas data frame drop an A removes the missing values. And next, let's create another data with data frame which has non values as well. Okay, so the fill na method It's going to fill NA or none values using the specified method. We can assign 0, okay, for the none values as in the example. So if you see data dot fill NA 0, and then we can also feed the fill NA method with in place is equal to true, okay, and also we can replace none values with the mean of the column as in the example on the very right hand side on the bottom. Pandas has another object type which is called series. So the series is one-dimensional array-like object. It contains array of data of any NumPy data type with associated indexes. Okay, so these indexes can be strings or integers or other data types. By default, the series will get indexing from 0 to n, where n is equal to size minus 1. If we have a look at the practice on the right hand side, let's import first, as always, the series object, and also let's import the data frame object from the pandas, okay? And let's assign pandas as PD, and then create our object as obj, and it takes the values 4, 7, minus 5, and 3 and from the object series. Okay, so when we print this object, you will see the indexes from 0 to 4 is excluded, and the values for each index, which is 4, 7, minus 5, 3 respectively, and you're going to see in the output the data type, which is integer 64 bits. Okay, and then when we print the object.index, and then you will see it starts from 0, stops at 4, and step is 1. And when we print the object.values, you're going to see only the values, which are 4, 7, minus 5, and 3. So within series, we can reference elements, array, and dictionary operations. Okay, so series can be constructed from a dictionary directly, and NumPy array operations can also be applied, which is going to preserve the index value link. If you have a look at on the left hand side, the example, let's create the series data as data. So it has some states like Texas, Ohio, Oregon, Utah, and it has the values for each state, which is 10, 20, 15, 18, respectively. So, and then we can define the states, okay, Texas, Ohio, Oregon, Iowa, and then here we create the series object as obj4. So this takes the parameter, the s data, okay, that's our data, the original data, and then we can also feed this series with the index parameter is equal to states, okay, and the output is going to be as you see on the left hand side on the bottom, the indexes are going to be the states, and then you will see the output. So as you see, the Iowa is the value of it is assigned to none because it's not defined above. Okay, and on the if you move to the next section in the middle, you will create another object too, and then the series can take the index parameter again. Let's assign these values with dbac, okay, and then when we print, you will see the indexes and the corresponding values and the data type, which is int64, and you can print the index of this data with object2.index. Okay, that's the syntax for that. And you can also print the values for each index, which is object2.values. You can also take just one corresponding value for an index. Let's pick the A index, which is the value of it 5, 8 minus 5, and then we can assign or modify one of the elements in this data. Let's change the D index its value as 10, and then when we print the elements corresponding to the rows DCA, and then you will see those values. And then we can also see the first two rows. We can print them, and the output is going to be 10, 7 for D, B respectively. With another syntax to get a value for an index is object2.a. It's going to return its value, which is -5. And on the very right hand side, we create another object series object, which is object3. Okay, and then we create another object, object4, and then it's going to be basically only the values that are greater than 0 within object3. Okay, so we can also do multiplication for those values, or we can take the square. So if you see 4 is going to be 16, 7 going to be 49, -5 is going to be 25, and 3 is going to be 9. So, and there's another syntax that if B is in object3, right, this is going to be return a boolean, which if the B is in object3, it's going to return true. If not, it's going to return false. I hope you enjoyed the lecture for Pandas library. So as well as practicing the examples shown in this lecture video, please also practice the Pandas Jupyter notebook that I provided from the chapter 5 of the textbook shown in this slide.